Which ones do you guys remember? Commutative. All right, I like that. Commutative, right? We're not going back to the 70s communes. It's not commutative, it's commutative.
Identity property?
All right, so associative. Got it. And then you got identity, additive, and multiplicative, right? Distributive, that would be the first one I would say, because that's the easiest one to find and to remember. Distributive. Oh, good, good. So then we got inverse. Additive and multiplicative. I like it. So these are the big three. Distributive, associative, commutative. Those are the big three. Yeah. Yep. And then guys, these two go together. Because once you know the identity, that tells you what the inverse has to be, because then you know what number to get back to. What's the additive identity?
Anything plus
0. Because that's what you add to keep the identity the same. Multiplicative identity? 1. So what's the inverse of A? What's the additive inverse of A? Negative A. I love it. So the additive inverse of 7, negative 7, so forth. What's the multiplicative inverse of A? Yeah, another name for the multiplicative inverse is reciprocal. So what's the multiplicative inverse of A? What's underneath the A? 1. Now flip it.
1 over 8.
1 over A. There we go. Is what you multiply by to make it become 1. So A times 1 over A. If I do A times 1 over A, what happens? Yeah, because the A's cancel. Good. So that's why we call it the multiplicative inverse. That word inverse means opposite. So this number I multiply by to kill it. It's to cancel it. It's how I cancel something multiplicatively. So, I mean, then I would just ask you, can you identify this property? What property would that be? No. What has to happen for it to be distributed? Yeah, it's got to be multiplying more than one term by something, so it distributes. Yeah. So that's definitely not distributive.
Identity?
Yeah, it's an identity. Yeah, it's the additive identity, because I added 0 and the number stayed the same. So additive identity.
And if you switch it, it'll give you the same answer, right?
Say again?
If you switch it, it'll give you the same answer.
It has nothing to do with the identity. Yeah, just if I add 0 to something, it stays the same. That's what that identity is. So what about this guy here? It's a little tiny bit equal. I didn't distribute anything.
Commutative.
Yeah, what actually happened from here to here, these terms. I guess that would be commutative. And to make it complete, you should say of addition. That's not much better. What about 2/3 times 3/2 equals 1? What is that an example of? Yeah, multiplicative inverse. I multiply by something and made them cancel. Bam, bam. So then that's multiplicative inverse. It's the opposite multiplicatively. Cool. Okay. So those are the kind of problems you would see from me. Is that all right? Is that cool? Yeah.
Could you show associative now? How would it look?
Here, you guys show me associative. How would I rewrite this to illustrate associative property?
7 times 4 times X.
Mm-hmm. Mm-hmm.
So in the parentheses, 7 times 4 times X.
Mm-mm.
4 times 7.
Good. All right. If you do 7 times 4 times x, you have used both associative and commutative, right? Do you guys see what I'm saying? You've not only moved the parentheses, you also moved things around. Hopefully it makes sense why I have to take some points off, because you did more than I asked. And I'm not sure which one you think is the right thing. I don't know. It's sort of like somebody might be covering their ass, man. Let me just do everything, and then something's got to be right. No. Just do the one thing I asked you to do. Is that cool? If it is, it'll be a bonus question, because it's extra credit. It would be really mean for me to say you don't have to do the homework, but then to have a problem show up, that would be really mean. Yes?
How many questions are going to be on the
So, how long is class normally? And how long do we have for the final exam?
2 hours.
2 hours. So it can't be any longer than a normal test. Yeah. So some of you guys might realize I'm going to have to really pick and choose, right? Now, obviously, like the last test we took, there were a ton of equations on there, right? Because that was the equation test, basically. You with me? So I can't possibly have that many equations for you to solve on the final, because I got a lot of other stuff to ask you. Does that make sense?
Yeah.
Okay, so that kind of thing's going to happen. I'm going to have types of problems, but not as many as I did on each test, because we just don't have that much time. We have the exact same amount of time as we do for a regular test. Yeah.
Can you go over each type so that we can
Each type of
problem, because I forgot from the beginning a lot of what we did. I mean, I think if you show us, then I'll remember how to address it on the test.
all right. So that's the purpose of the practice final, in a sense.
So it's going to be just like this.
Not necessarily. Not just like this. If you are able to do this entire practice final without any trouble, you should be ready for the final. That does not mean that this is representative of every possible problem I could give you, right? The ideas that are on this will be on the test itself. There it is. Yes? Oh, okay. So the biggest mistake on that 2B is to write that less than part backwards. Somebody just tell me. If I got 7 apples, you got 3 less than I do. How many apples do you have? 4. What'd you do to get 4? 7 minus 3. So you have 3 less than 7. And what you just did naturally was 7 minus 3. And I've talked about that. It's so evil, though, I got to talk about it a few times. Less than, you end up writing it backwards. And it's not math's fault. It's freaking English grammar. As some of you, where English is not your first language, might attest to, English grammar is freaky. So that one says 12 less than twice a number, right? So 12 less than twice. What is twice the number? 2x. So then what's 12 less than that? Yeah, subtract 12 from it. Is equals. That number, x, increased by 3. Cool. It's just like direct translation almost, except that the English grammar is backwards from what it really is, right? And then, of course, I ask you to solve it. So how do you solve this equation? What do you do?
12 on the side.
Yeah, which way do you want to move your variables? Let's start there.
The number or
I want to minus x. And I want to do that so that the x's, not only so they show up on the side, but also so they're not negative. Because negatives are a place where it's really easy to make mistakes. So I could subtract 2x, couldn't I? But doesn't that make a negative x over there? And if I have a choice, I'm not going to let that happen. Right? So minus x minus x. And then you add 12. So it doesn't really matter if you add 12 first or not. I just want to make that point about if you have a choice, keep the x's positive. Like all you need is x's on one side, numbers on the other. It doesn't matter which side they end up on. So then you add 12. 15, cool. And then you can check it if you want to, plug it back in. Right? What's twice 15? 30 minus 12. 18. And what's 15 plus 3? 18. Check. That's the one number that makes this statement true. That's what it means to solve an equation, is to find the value that makes this statement true. Okay? Cool? Yes? No. Yeah, I mean, I could have done plus 12 at the same time. Yeah, so the more comfortable you feel with solving equations, the more things you could do. I could have done minus x and plus 12 at the same time. If you do that, I'm not going to take out points as long as you show me what you're doing. What I can't accept is something like this. That is not algebra. It really isn't. And this is where people start to disconnect. They say, then why do we need algebra? I can do that without algebra. Because that's an easy freaking equation. So the whole purpose of this is to try to get you used to how algebra works, so that when the equations do get more disgusting, you're able to apply algebra to it. The algebra always works. In my head, don't always work. There's too much shit to keep in my head at once. Algebra's going to save my ass. But we're trying to get used to it. So what's the right way, of course? This is not good. Everybody understand this is not. That's the right answer. I don't care. Because this is all about the process. Right? You can always luck into the right answer. I need to see that you know the process. So what is the right process to use here, of course?
Wonderful.
Yeah, this is the algebra. When I say show algebraic steps, this is what I mean. Algebra says if you do something to one side, you must do it to the other side to keep them equal. And then x is 13. Now that's the correct way. And some students just are like, well, 13 is what I got. That's the right answer. But that's not. It's the process that matters, right? That's what I need to see. I need to see evidence that you understand the process. Cool. I like it. Have you guys all tried out the practice test? It sounds like a few of you guys have. Has everybody gotten? I don't know if I have any more copies, to be honest. Yeah.
When you say make a table of values and graph the equation, how many do you have to do?
3.
3 now.
Yeah. So if it's a straight line, you only need 2 points to make a straight line, so why do we need that third point? Just to make sure that it's not like over here, then I'm like, oh shit, one of the points is wrong. This is the check point to make sure that you are going in the right direction. Okay. So that first one, I would take a few different ways to say it in words, because you could just say it in words as it is. How do you say that fraction in words? Yeah, so just write that out in words. Or I would accept it if you made it into a decimal first, and then you said it in words for what the decimal is. That would be beautiful too. They're both the same thing mathematically. So 13/25ths, in fact, that's what I put down on the answer key. Yeah.
On the very last one, the 1.12%.
Yes.
The fraction part, how would you write the fraction part?
Oh, I wouldn't go straight to there. So 1.12% is what is a decimal? No, a decimal, yeah. So what do I do to make it into a pure decimal number? Right now it's a percentage that has a decimal in it. That doesn't mean, yeah, move it back twice.
You have to have zero.
Good. So once, twice, there's a 0 there. So 0.0112. 10 center shouts 10,000. Now you know how to do it. Fraction, 112,
Over
10,000.
Okay, that means you reduce it or just leave it like that?
Part of me would actually rather you leave it like this. Because some people know where the fraction buttons are in the calculator. And if I don't see this, I just see the reduced form, I start to wonder, did the calculator do this for you? So I actually would rather see this not reduced. Yeah, to be honest. How do I make 13/25 into anything else? Yeah, I could divide. I could always divide a fraction. That'll always work. But what is a slightly better way? Yeah, how do I make the bottom become 100? Multiply by 4. So if you forget that, you can always divide a fraction because that's how you make it a decimal. And then you move the decimal over to make it a percent. Beautiful. That'll always work. But if you happen to notice, the bottom can become 100 easy. The hell yeah, I'm going to do that. Why would I do that? Because percent means out of 100. I love it. So what's the top of this? 52 out of 100. So what is that as a decimal? Yeah, 0.52. So what is that? And as a percent, I already know it already right here. 52%. And then in words, it would be, yeah, 52 hundredths. I love it.
So what would be the 13/25?
No, so again, you could either say 13/25 or you could say 52 hundredths. They're both mathematically the same. So I would take either wording. I like it. Is there another part of that specifically, or just I desperately? Here's the thing I want you to realize. This is the thing I've been trying to say the entire semester. The process. Somebody else is tweeting it out. The process you use to do something doesn't change. So there's one problem, number 6, repeated over and over and over. How do you go from decimal to percent? Move it over. How to go from percent to decimal? Move it the other way, right? How do I go from fraction? I try to make it out of 100, or make it into a decimal first. I've got a couple of options for that process. Yeah.
I missed the part where, like, the one, not the most recent one, but the one above that. What do we rate for the inwards part?
Which one, sir? Oh, the inwards for which one?
The 1.12%.
Oh, yeah. So it would just be this. It would be 112 10,000.
Oh, okay.
Yeah. Got to make sure you get that lisp. The 10,000. Cool.
And number 5?
Oh, yeah. Good. So you got an Xbox 360. I'm kind of thinking myself a little bit now. And bundle of games, right? Bundle of games. So I'm going to try to create an equation out of this situation. So the cost of the Xbox is 3 times as much as the cost of the games. So if only I knew what, then I could figure out the price of.
The cost of each game.
If I knew the cost of the games, then the Xbox would be 3 times that. Well, how much do the games cost? I have no idea. So then what do we put there? X. Or Y, or M, or your favorite Russian letter, a little happy face, some symbol that represents, we don't know this. So why do we do that in algebra? Because now I can work with it. I can't work with blank space. But now, if that's X, how much does the Xbox 360 cost? 3X. 3 times as much. Let me stop for a minute. So I don't know either of these, but I know a relationship between the two. I know that whatever this is, that's 3 times as much. So I got to give this one a name first. I call it x. Because then this guy will be 3 times that. That will be his name, 3x. So I am going literally from English to mathish. This is the English names. These are the math names. So what's better about the math names is I can work with them. I can't do Xbox 360 plus bundle. What the hell's that? It's no freaking like terms. But now I can do, what are these supposed to do together? What's it say?
Multiply.
So an Xbox 360 console and a bundle of games are sold for $380 total, right? 380. So if you do what with these? Yes, if you add them, it's supposed to become 380. I like it. So if you take the Xbox plus the games, it's got to be that $380 that they said. So together, they're $380. Now, can you solve that for X? Cool. That's all about taking a lot of words, but then making it into a math statement. Why can I do that? Because I have two things that together they make 380, and they also have a relationship to each other. One is 3 times the other one. So I should be able to represent it as a total of 2 things that are related to each other. And that mathematically, the related to each other becomes like terms. What's 3x and x?
4x.
4x. And then I just
Divide by 4.
divide by 4.
815.
Ooh, 95.
95.
Yeah.
Yes.
So times that times 3.
Yeah, so the bundle of games is $95. And good, the Xbox is 3 times X, and X is 95. So 3 times 95,
3 times.
285. How can you check yourself? How do you know that's right? Yeah, they got to add the 380, and thank God they do. If you add them, it actually does make $380.
Why did you get 95?
Yeah.
How do you mean?
That's the answer.
380
Uh-huh.
divided by 4. That's how I got 95. Don't look at me weird. 4 into 380. 4 goes into 38. 9 times. 9 times 4 is 36. 4 goes into 20.
Okay.
Cost of bundle.
Yeah, so these are the cost of.
That's your
I like it. So not as bad as it first sounds if you let it be not that bad. Something's going to be X. The other thing is going to be built off of that. If it was 3 times as much, 3X. If it was $20 more, it would be X plus 20.
How are we?
I don't know.
No, it's just like I just want to know because it's kind of hard to put together that equation. Like, you know what I mean? What would you suggest for us to do to make sure we get that exact equation? Because at the equation, it's cake.
True, exactly. I would suggest you do exactly what I did. The very first step of a problem like that is not math at all. The very first step, I don't care about the 3 times. I don't care about the $380. All I care about is what are the players in the problem. There's an Xbox and there's a bundle of games. I'll write those down. Those 2 need math names now, right? So say which one does the other one depend on? The bundle. So I give it X, and then the other one's going to build off of that.
Can you do it in the tax rate?
Oh, sure, yeah. Alright, so we'll do a couple different kinds. This is the kind that happens most often, of course. We go to a store, shirt's $20 or something, and then there's a 6% sales tax or something on top of it. How do I figure out the total cost for that shirt, including tax? What do I do?
You'd add them.
Add 20 and 6.
No, you wouldn't add. No.
Okay, all right. So 6% is 0.06, true. But then would I just add 0.06 to 20? That doesn't make any sense, right? Because then it would be 6 cents always. Buy a car, 6% sales tax rate, 6 cents. We're going to add 6 cents on. You're like, oh shit, yeah. Sounds good to me. But it's 6% of what? $20. So that's the thing right there. People don't understand that percent means out of 100, right? That doesn't mean that 6% is always going to be of 100. So if it was a $100 shirt, then the tax would be $6. Because this 6% means $6 for every $100. But this is $20. Not 100, so it should be less than $6 tax, right? So to find out, so I take 6% of 20. I picked the wrong one up. How do I do 6% of 20? Yeah, multiply. So of means multiply, right? So 6%, like you said, is 0.06. Of is multiply.
$1.20.
Yes, $1.20.
$1.20.
This is not math class math. This is just living out the freaking world math is what this is, right? You have to know how to work with percentages to make sure people aren't ripping you off. Or if you don't care, then get ripped off, right? So how do I find a percentage of something? How do I find 50% tip? I take 15% of the meal cost. 6% tax, I take 6% of the shirt, of the cost. It's always of something. I'm not just going to add 6 cents on top of something. I'm not going to 6% markdown and then take 6 cents off. I'm like, well, wow, thanks. All right, it's got to be 6% of the price. So what do I do with this money? What's this? That's the tax amount. I love it. And of course, I'm going to do like I heard somebody say, I'm going to add that on top. So the shirt costs $20 for the shirt, $1.20 for the tax, so $21.20 to get out the store. I like it. So what if I had a $1,700 laptop on sale for 11% off? How would you figure out? Can you take a minute and figure out what the new sale price is? One huge red flag for your final answer is if it was more than this. I don't want to go to your store, right? This is on sale for that much off. So I'm going to subtract. Now here it was tax. I'm going to add that bad boy on.
Is it 1,513?
Well, wait. We'll check you.
With your minus?
So what do you got to figure out first? Yeah, 11% of that will be the amount that I'm going to subtract, right? Let me tell you real quick. You can do that in the calculator. What's 11% as a decimal? 0.11. 0.11 times 1,700. Just to tell you how I do this in my head. 10% of something, just move the decimal back once. 10% is 1/10 of something. So that would be 170. Now, just take a second. I know you can do this on the calculator. I don't care. 10% of 1,700 is 170. Because 10% is 1/10 of it, just moves the decimal back once. What's 1% of it then? I would move the decimal back again. Yeah, 17. So what's 11% of 1,700? This plus this makes 11%, don't it? So 170 and 17 is 187.
187.
That's what you get when you do 0.11 times 1,700. If you don't understand what I just said, it's not the end of the world. It is a little bit for me, but not the end of the world, really. Right? So you get 187 here, and what am I going to do with that money? Subtract it, right? I'm going to do whatever I want to with that because I'm going to have that's my savings. Although you end up paying how much? Like Daniel said.
1,550.
Wow. Okay, now, those are two examples where everything's known ahead of time. You just got to figure out what the new price is.
And
The
then
one that,
plus tax that will go up, right?
yeah, exactly.
Yeah.
Yeah.
So that wouldn't be the final price plus tax.
Well, I didn't give you that information, so that's how much we know. And it's the tax-free shop. Why not? Yeah, it's the duty-free store. It's what is it? Connecticut has no sale. I can't remember. Some state that has no sales tax. There. Huh? New Hampshire? I knew it was somewhere up there. So this is the one that killed people. If I have something that's normally $280, and now it's on sale for what you got, Jeff? I don't know, buddy. Let's say $228. See if that comes out nice. What was the sale percentage? What was the discount percent? So I want you to realize something. If do you see how that's the reverse of that? They're opposites. There I know the percentage. Here I don't. But notice, what's the very first thing I did when I knew the percentage? I figured out the amount that was going to change. And then I changed it. So here, I first have to figure out how much did this change by. I mean, because they're opposites of each other, they should have the same steps, kind of in reverse. So how much did this change by? $52. I want you to notice something else. What did I do with that 11%? I multiplied it by the original price, right? This is the backwards. This is the opposite problem. So I'm going to take that change, I'm going to divide it by the original price to figure out what the percentage off was. So that's that change divided by original formula to get a percentage. $52 divided by 280. I think it comes out nice. Hopefully, I don't know.
0.1.
0.1857114.
All right, so it didn't come out nice. I was trying. 0.185, blah, blah, blah. All right, so on the test, I would say round it to like the thousandths place. What would that be to the thousandths place? 0 point.
1/8.
Where's the thousands place? Tenths, hundreds. That one. So 0.186 or 18.6%.
8 would be tenths.
Yeah, 8 would be in the tenths place. No, 8's the hundredths place. Come on. Tenths,
Or
hundredths,
hundreds. Yeah.
thousands. Okay.
So if we just look at 0.186, that'd be correct?
Second? Yeah, that's fine. To make it a percentage, 18.6%. Right? Oh, yeah. 42. Oh, nice. All right. So it's always like that. If last year 3,500 people showed up to some concert, and this year only 2,700 people showed up, what was the percent decrease? What was the percent change? Guess what formula I'm going to use? Change divided by original. So how much did the numbers change? How much did the amount of people change by? 800. So the change is 800 divided by the original 3,500. And then whatever the hell that is.
0.0228.
It's like 2.28%. Let's do this. Let's do, here's the 3 that are not on the answer key while I'm thinking about it. The answer key I had from last semester, I had changed number 3. I put some different formulas in there because I eliminated that fraction and decimal section of chapter 8, the solving the equations chapter. So I had some fractions and decimal equations on the old practice test, so I changed them out. I didn't feel like redoing the whole practice test, so I'm like, I'll just do those in class. So somebody help me out. What's the equation you got for 3b, since I gave all my practice ones away? 4 times x minus 2?
Yes.
Minus x.
So what would I do first on this one? Yeah, I want to distribute. Now, please let it make sense. I can't add 2 to both sides. I can't subtract that x from both sides or something because they're stuck inside. They're stuck. So that's why the first thing I do is distribute so they're all free to move around. You're now free to move around the equation. So in the 4 goes and you get
4x minus 8 minus x.
I like it. So we just change that piece, bam, and then the rest of it stays the same. Now what can I do on this side?
X,
X
4x,
minus 4.
Yeah. How many x's you got left?
3x,
3 x's.
minus 8.
Now who's in the wrong place? Yeah, the 8's in the wrong place.
8
Stupid
will
8.
go.
So you add 8.
Add 8.
Add 8. 13. No, 13 is Divided 3
Divide by 3.
by 3.
Bam. If you want to make a mixed number, feel free. If I don't say to leave your answer a certain way,
4.
I'd rather actually see it as the fraction. Don't automatically reach for the calculator.
No complete. 4 3 3 3. No complete.
It's complete. This is the most accurate way you can answer this question. Yeah. Now, if you want to make it into a mixed number or something,
4 3 3 3.
so that's 3B. 3D is also not on the answer key. So what's 3D say? What's mine say? Sweet.
3B minus 5
3B minus 5
times 2 minus 3
times 2
yes
Minus
minus B
minus B.
equals
equals
B plus 4 times B minus 5
Oh, it's not like this?
yes plus 3B.
Ooh, Jeff.
There you go.
All right. I like it.
36 down.
All right, so the very first thing your eyes should gravitate towards are the two places where you can distribute. I like it. That's the first thing you look for. You don't care about everything else. Everything else just kind of comes for the ride. So that 3B is still there. Good. Minus 10.
Positive.
Good. The biggest mistake people make, I get all kinds of things here. I get it stays the same. I get it becomes plus. I get it's minus 5B. It's supposed to be plus 5B. And can you tell, if you make a mistake there, you have no chance to get the equation right. So I'll take points off for that one piece, and then I'll grade the rest of it. If you did all the steps right, you're not going to get more points taken off. You understand? Because again, it's all about the process. You make a mistake here, I'm going to grade your process after. I hated the teachers that would say, well, you made a mistake. You're never going to get right. Full points off. Equals, what can you do over there?
B 4B minus 20.
And the plus 3B is still sitting out there. I like it. So everything else stayed the same, and I just distributed and wrote that into place. Everything else has stayed the same.
8B.
And now I look at each side. I don't try to start moving stuff around, because this is where you start to forget things. Consolidate each side first. So what can you put together here?
8B
Yeah, the B's go together.
minus B.
And over here I got,
8B.
yeah, 5B plus 3B is 8B.
8B minus 20.
Okay, I like it.
Let's count B or Q.
So how do I get the B's together? I want them to disappear here, so what do I have to do?
Minus.
And this is where people, I love this. This is where people often make jokes about, oh, they put the alphabet in my math with the shit. And then when they want to cancel, people try to save them. I hate you, but I don't want you to die. B, they're dead. All the B's are dead. Right? Dead. I get negative 10 equals negative 20. You have not just discovered that negative 10 is the same as negative 20.
No solution.
Remember, the point of the equation is to figure out what values of the variable make it work. This statement is never true. Therefore, this statement can never be true. No solution.
No solution.
Bam. I like it. And then the last one that's not on here is 3E. What's 3E say?
3x minus 2 equals 4 times x minus 1 minus x.
I don't know why I beat this idea to the ground, but all. So again, the steps. You get 3x minus 2 equals 3x minus 4. You start to see the idea. These are going to cancel. When is that true?
No solution.
Never, so no solution. If I would have gotten negative 4 equals negative 4, that is always true. the answer would have been all real numbers. So don't circle this. That's bad, because that's not true. Your answer is always what values make this work. No value. There's no solution. There's no values that make that equation work. It's never true. So if you do everything right and then you get a little lost here, you're only going to lose a few points. You're not going to lose a ton of points because I'm grading the process of how do you solve an equation. Yeah.
Number 4 on the back. Is you right now, first, can we just add any number that we want? Or does it have to be like 1?
Which one are we looking at?
Number 4 versus creating a table. On that. The graph.
Oh, the graph.
Yeah. So
Number-
if you don't use any number we want,
Shoot, is there another difference? Yes. You can. Yeah.
but it has to fit on the graph. As long as it fits on.
Yeah, exactly. Yeah. Oh, okay. You got to remember, I don't have any more of those.
Sorry,
copies.
sorry.
That's my bad. That's why I was like, shit. Is there more that's different from the front? No, okay. Yeah, so when I say, so like somebody asked earlier, how many points do we need to use then? 3.
Oh, you only need 3.
Yeah, you need 3 points. Yeah, you really only need 2 points to make any line. 1 point's not good enough, because then it's like, holy shit, there's an infinite number of lines that go through. 2 points, now there's only 1 line, but why do you do that 3rd point? Just to make sure everything went okay with the other 2. I like it.
And then you choose like certain numbers that should make a line.
Yeah. What's up?
I said you look confused.
Oh, well, no, I mean, just, yeah, if you don't want to pay attention, you don't have to. It just distracts me sometimes.
So you could use numbers.
Yes. But so, I mean, if you pick something and you get like an output of 87, don't use that point. You do something else, right?
Okay.
Normally, I would use -1, 0, 1.
Yeah.
That's a nice little packet of numbers to try to use. In fact, that's what I used on the answer key for that problem number 8 for the practice final. So here, let me give you the answer key before I forget to do that. Oh, good. Yeah, that's it. That's all I got. So you know the overhearing a little conversation. When you have an equation like this, you can make either one of these anything you want it to be. But then the minute you do put something into either one of these, the other one has to be a very specific thing, the one that actually makes it work. So when it's written like this, I think of my x as my input. Why? Because it's already solved for y. So then I can think about, if I make x 0, well, how can I do that? Well, because x can be anything I want it to be. So I always love when people are like, where'd you get the 0 from? Out of my head. Make X anything I wanted to. You plug it in and you get Y has to be -1 to make it work. So there's one variable, you make whatever the hell you want to. And we call that one, the official name of that one is the independent variable. It could be whatever. The other one's going to be the dependent. It depends on what you picked for X. Y depends on what you picked for X. Do you guys see that? That's why when I graph these points, they have to have a pattern to them. If it's a line, of course, it's just going to be a straight line. If there was a square there, it's still going to have a pattern to the points. Because it can't just be any points they want to be. They have to work in the equation. So there should be some visual pattern to them. So if it was cubed, it could actually look like this. Whee! Whee! Okay.
So do it for 9. Which is 9
Okay.
and 11.
Oh, sweet. Beautiful. Good. X is our normal number line that we've used before. Y is the new number line that we put at a right angle to that. Yeah. Okay. That's not too bad.